Birth and generation of computers. During the Second World War, there were concerns about how to calculate the logistics of such a large scale battle. The United States needed to calculate ballistics, deploy massive amounts of troops, and crack secret codes. The military started a number of research projects to try and build computers that could help with these tasks and more. In 1931, the US Navy and IBM began working together to build a general purpose computer called the Mark I. It was the first computer to use the base 2 binary system, was programmable, and made of vacuum tubes, relays, magnets, and gears. The Mark I was completed in 1944. The Mark I had a memory for 72 numbers and could perform 23-digit multiplication in 4 seconds. It was operational for 15 years and performed many calculations for the US Navy during World War II. This is Mark I. These are vacuum tubes used in Mark I. The Mark I was still a mix of electronic and mechanical. At the same time as the Mark I, however, there was another project taking place. During World War II, the United States Army was building new artillery that required firing tables. These firing tables were created by way of intense mathematical calculation that took a very long time to manually compute. To help make this process quicker, the Army started a project in 1943 to build a completely electronic computing device. J. Presper Eckert and John Maclay headed the project and eventually created the electronic numerical integrator and calculator Eniac, which was completed in 1946. The Eniac had 18,000 vacuum tubes and absolutely gigantic, 100 feet long, 10 feet high and 30 tons. It was about 1,000 times faster than the Mark I at multiplying numbers and 300 times faster at addition. People behind the Eniac: John Presper Eckert and John Maclay. This is Eniac, gigantic in size. Though the computers developed in the Second World War were definitely computers, they were not the kind of computers we are used to in modern times. John von Neumann helped work on the Eniac and figured out how to make computers even better. The Eniac was programmed externally with wires, connectors, and plugs. Von Neumann wanted to make programming something that was internalized. Instead of rerouting wires and plugs, a person could write a different sequence of instructions that changes the way a computer runs. Neumann created the idea of the stored computer program, which is still implemented today in computers that use the von Neumann architecture. Now we will see generation of computers. First generation, 1950 to 1957. First generation computers used thermionic tubes or vacuum tubes as basic elements. The key concept of a stored program was introduced by John von Neumann. Programs and their data were located in the same memory as they are today. Assembly language was used to prepare programs and was translated into machine language for execution. Basic arithmetic operations were performed in a few milliseconds. Input-output functions were performed by devices similar to typewriters. Magnetic core memories and magnetic tape storage devices were also developed. Examples of first generation computers are Eniac, electronic numerical integrator and calculator; EDVAC, electronic discrete variable automatic computer; EDSAC, electronic delay storage automatic calculator; Mark I, and UNIVAC, universal automatic computer. EDVAC with Neumann. ETSAC, UNIVAC. This is a picture of a first generation computer. Vacuum tubes were the only electronic components available during those days. Vacuum technology made possible the advent of electronic digital computers. These computers were the fastest calculating devices of their time. They could perform computations in milliseconds. The first generation computers had some disadvantages. It was too bulky in size and hence very large space required. It was unreliable. Thousands of vacuum tubes that were used emitted large amount of heat and burnt out frequently. High power consumption and short lifespan. Air conditioning was required. Frequent hardware failure. Constant maintenance required. Commercial production was difficult and costly. Second generation, 1957 to 1965. The second generation began with the advent of transistor circuitry. Magnetic cord and magnetic drum storage devices were widely used in second generation. The higher reliability of computers and large memory availability led to the development of high-level languages like Fortran, COBOL, ALGOL, etc., making the preparation of application programs much easier. System programs called compilers were developed to translate the high-level language programs into corresponding executable machine language form. IBM became the major computer manufacturer during this time. This is a second generation computer. The advantages of second generation computer: compared to the first generation computers, it was smaller in size, lower power consumption and hence reduced running cost, less prone to hardware failures, better portability, reduced manufacturing cost and hence wider commercial use. The disadvantages: air conditioning was required, frequent maintenance was required, commercial production was difficult and costly. Third generation, 1965 to 1975. The third generation of computing spanned from 1965 to 1975. During this time, integrated circuits with transistors, resistors and capacitors were etched onto a piece of silicon. This reduced the price and size of computers, adding to a general trend in the computing industry of miniaturization. In 1960, the Digital Equipment Corporation introduced the Program Data Processor 1 or PDP-1, which can be called the first mini computer due to its relatively small size. The PDP-1 was the computer that ran the very first video game called Space War, written in 1962. Email originated sometime between 1961 and 66, allowing computer users to send messages to each other as long as they were connected through a network. This is PDP-1. Advantages of the third generation computers: smaller in size as compared to previous generation of computers, lower heat generated, maintenance cost was low because hardware failures were rare, easily portable because of its size, commercial production was easier and cheaper. Disadvantages: air conditioning required in many cases, higher sophisticated technology required for the manufacture of IC chips. Fourth generation, 1975 to 1985. The fourth generation of computing started in 1975. Computer technology had advanced so rapidly that computers could fit in something the size of a typewriter. These were called microcomputers, the first one being the Altair 8800. The Altair 8800 debuted in 1975 as a mail-order hobby kit. Many people acknowledge the Altair 8800 as the computer that sparked the modern computer revolution especially since Bill Gates and Paul Allen founded Microsoft with a programming language called Altair Basic, made specifically for the 8800. Altair 8800. A small company called Apple Computer Incorporated was established in 1976 and single-handedly changed the industry forever. Steve Wozniak and Steve Jobs began to sell their Apple I computer that same year, and it quickly gained popularity. It came with a keyboard and only required a monitor to be plugged into the back of the system, which was a novel idea for computers at that time. The Apple II was released the next year and was the first mass-produced microcomputer to be commercially sold, and also ushered in the era of personal computing. In 1981, Microsoft Disk Operating System MS-DOS was released to run on the Intel 8086 microprocessor. Over the next few years, MS-DOS became the most popular operating system in the world, eventually leading to Microsoft Windows 1.0 being released in 1985. In 1984, Apple introduced their Mac OS, which was the first operating system to be completely graphical. Both Mac OS and Windows used pull-down menus, icons, and windows to make computing more user-friendly. Computers now being controlled with a mouse as well as keyboard. The first mouse was developed in 1981 by Xerox. This is the first mouse developed in 1981. Software became much more common and diverse during this period with the development of spreadsheets, databases, and drawing programs. Computer networks and email became much more prevalent as well. The first truly portable computer, called the Osborne 1, was released in 1981. Portable computers like the TRS-80, Model 100, 102, and IBM 5155 followed afterward. Not all the computers of the time were small, of course. There was still being supercomputers built with the aim of being as fast as possible. These supercomputers were sold to companies, universities, and the military. An example of one such supercomputer is the Cray 1, which was released in 1976 by Cray Research. It became one of the best known and most successful supercomputers ever for its unique design and fast speed of 250 MFLOPS. Osborne 1. Advantages of the 4th generation computers: smallest in size because of high density of components in a single chip. It was more reliable. Heat generator is negligible compared to the previous generations. Air conditioning was not required in many cases. Much faster in computation. Hardware failure is negligible and hence minimal maintenance cost. Easily portable because of their small size. Totally general purpose. Minimal labor cost involved at assembly stage. Cheapest among all generations. The major disadvantage: highly sophisticated technology was required for the manufacture of VLSI chips. 5th generation, 1985 to 1990. The changes that have occurred since 1985 are plentiful. Computers have gotten tinier, more reliable, and many times faster. Computers are mostly built using components from many different corporations. For this reason, it is easier to focus on specific component advancements. Intel and AMD Advanced Micro Devices are the main computer processor companies in the world today and are constant rivals. There are many different personal computer companies that usually sell their hardware with a Microsoft Windows operating system pre-installed. Apple has a wide line of hardware and software as well. Computer graphics have gotten very powerful and are able to display full three-dimensional graphics at high resolution. Sixth generation, 1990 till date. In the sixth generation, networking technology is spreading at a high speed. Huge growth of wide area networking can be seen. Networking technology is becoming more widespread nowadays. Workstation technology continued to improve also. The software industry has grown a lot as well, offering all kinds of programs for almost anything you can think of. Microsoft Windows still dominates the operating system scene. In 1995, Microsoft released Windows 95, an operating system that catapulted them to a new level of dominance. In 1999, Apple revamped its operating system with the release of Mac OS X. In 1991, Linus Torvalds wrote the Linux kernel that has since spawned countless open source operating systems and open source software. In 2008, the IBM Roadrunner was introduced as the fastest computer in the world. Fast supercomputers aid in the production of movie special effects and the making of computer animated movies. The sixth generation has brought about microcontroller technology. Microcontrollers are embedded inside some other devices so that they can control the features or actions of the product. These microcontroller devices work as small computers inside the devices and now serve as essential components in most machines. The sixth generation is a period of artificial intelligence, VAR, voice recognition software that you can find nowadays in vehicles. You give voice command, and virtual office assistants, robots. Even in restaurants, there are robots. These pictures will help you to know how far we have advanced in the case of technology. We have smart devices, in smallest form, handy in nature, futuristic designs, can control the devices using our own hands without touching it, virtual game, and finally artificial intelligence. Thank you.